the management of the Portuguese experience in space. So today we are going to go through a group of colleagues that are actually going to discuss how Portugal is coping with this activity in space. So in order to actually start this or to kick off this discussion, I put some slides together, and I bring some slides from the activity of IT, especially on the group of radio systems, and the activity of IT in several projects of space. And I want to go very fast to these activities, including very past projects where IT actually was involved in the past on evaluating transistors and gallium nitride approaches for space. IT has been exploring links and microwave links from satellite to Earth, from projects for the European Space Agency and others. IT has been involved in several activities with the aeronautical and the Portuguese Air Force. And I want to give you a snapshot of some projects that are running in IT at this moment. One is called the Infant, which is a project that actually is going to create one of our first Portuguese satellites to be flying, hopefully in the future, with an objective of synthetic aperture radars and actually with the Earth observation idea. IT is also involved with University of Austin and FASEC on the development of Magal constellation, which again is very focused on telecommunication, but also on an Earth observation approach. IT has been involved with Evaleo Technologies on some of new ideas for software-defined radio to put on board of satellites and how to incorporate these new type of radio technologies in satellites. Today we are going also to hear a colleague from Sinuta, where we are involved in a new project called STRX, where actually we are building some kind of receivers for new space technologies and the new telecommunication paradigm change that is going to appear in the future. Well, IT has been developing some MMICs with the European Space Agency and with other partners for space, and also collaborating in development of new technology for future satellite communications with Portuguese companies. As you can see in most of these activities that I'm showing, IT has been involved with a significant number of companies, and also on some ideas on propagation models for satellite to Earth communications. And having this in mind, and today you also heard about the SCA platform that IT is involved. There are a significant number of other activities involving optical networks. The IT team in Lisbon also is collaborating with the European Space Agency for CubeSat manufacturing. So having all this in mind, today we decide to put some of the companies together and invite also PT Space, so the Portuguese Aerospace Corporation, and actually put them all together in the same room to hear about what is Portugal doing for space exploration and for space developments. So the program today will include a first talk from Ricardo Conde, which is the president of PT Space, and he will show a little bit of what has been done and what is being done in this new framework of PT Space. Then we are going to have Arlindo Marques talking about FASEC approach to space in Portugal. We are going to hear also Ricardo Correia from a vision of Sinuta for the new space. And finally, we are going to hear Rodolfo Martins from Evaleo Technologies talking about how to embed and how to bring computers inside satellites and how Portugal is contributing to this new challenge that is going to appear very soon in space, and these new activities that are actually running for space. So my idea today is we can hear each one of these speakers, and then we are going to have a small panel discussion, and we will ask you at the end to put questions to discuss some of these activities with our speakers today. So I will start with Ricardo Conta. I will stop my share at this moment. Yeah, Ricardo is already here. I don't know if you want to share any slides.
Good afternoon, everyone. And I have a presentation here, but mainly what I want to do is to exchange some words and some thoughts with the expectations that our space community is putting in this new moment that we are living, right? But before that, Nuno, I want to also to thank you for thanks to the invitation to the Portuguese Space Agency, which is an honor, particular for me to be here, because when I was a student in IST, in technical, this conference, telecommunication conference, was at that time for our space community a milestone, very important milestone, because it was a moment I remember very well. We were expected to listen our stars, our telecommunications experts, and some new technologies. I remember very well, new approach of software-defined radio. At that time, I'm talking about 93, this decade. So, and also it's also an honor for me to share these or be part of this conference, where some of the persons were my professors, my teachers. I remember Carlos Fernandes from Lisbon, and also Salema, Professor Salema, which is it was also my professor. So it is an honor to be here. But let me try to share Nuno, here my screen. Let me see if I can do it, where I can share these. Share screen, and is this one, I guess. So please let me know if you see my screen.
Yeah, we are seeing, yes.
Okay, very good. I will try to put it in the presentation modes. It's okay?
Yeah, it's perfect. Thank you.
Very good. So, well, I'm not in the beginning. I'm in the middle of. Well, let me just start with a brief introduction that Portugal is not a new actor in space. Indeed, we have some, as a nation, some track records, in particular 20 years that we are, when we signed the convention to HISA convention, we start a long journey, 20 years of building capacities. And this is one of, when we signed the convention to HISA, was at that time a remarkable milestone for Portugal. Because at that time we start to be part of something bigger than us. And since then, there are many companies. They are growing their activities. New companies emerged, and now I should say that we have a very, let's say, vibrant ecosystem. But also, we are now entering the new phase that we don't want only to be a country or a small country that supply subsystems. We want to be in another level, the programmatic level. And this is why in 2018, so roughly 2 years ago, we created the national strategy for space. At the end, it was an old ambition from the older community to drive the country and lead the country to a new perspectives, taking advantage of the new space. I will address this also later. And 1 year later, so in 2019, it was created the Portuguese Space Agency. I should say this is the the youngest space agency in Europe. And what we want to do is to create and all the conditions to leverage the current ecosystem. But more than this, we want to implement some national programs for space. And this is the challenge here. This is exactly what I want to share with you in this conference. And one of our the main objectives as an agency is Portugal to become a new actor in space and a space nation. Of course, we have these raw materials that's surrounding us. This is the Atlantic. But as I said, we want to leverage an industrial agenda for space in Portugal. And of course, we are doing this in really close cooperation with other nations, and particularly in the European environment. As you know, there are now a moment where our European institutions are really involved in the discussion about this, the European Space Program, and not only with HISA, but also the GSTA, and now what we call the future OISPA, is a new agency for space for the European Commission. So for that, and particularly to be a nation, in a space nation, let's say like this, we need to have a national program. Otherwise, in the other words, we need to be a fly nation. I will explain what I mean about the fly nation. And for that, we are creating and launch the great challenges for space. And I present to you here this, some topics that represent the challenge that we are implementing these it's 10 years, so 9 years. So since we launched this, in fact, last year, and this is a target for this decade. So the first one is the satellite Atlantic constellation. So it is a federated Atlantic a constellation together with other nations. And I will explain better about what are our objectives for about the Atlantic constellation. The second one, and really ambitious challenge, is the Digital Planet, which is a multi-platform for Earth observation data. And this is mainly to develop the downstream applications, but this is also to foster the discussion about the open data policy. As you know, we have now many applications developed by using the open data from the navigations of the GPS and also Galileo or the platforms. But we have these applications running now, and they are market because the data is quite easy to have access to this data, the navigation data. We need to promote the same for Earth observation. That means to create the downstream applications. And this is the service. And you'll see this will represent a growth of at least 7% in the upcoming years. And this is where the business is. So the third is 5G. I saw that you talk a lot here in this conference about the 5G. We are promoting and attract some companies using 5G by satellite, particularly in the level of B2B, so business to business. And one of our targets is the cover to the remote regions, because we know that the terrestrial network for 5G will be concentrated in the main urban areas. And one topic that we'll address is a quantum communications that I will probably reserve some seconds later to talk about this and the initiatives that we want to build with you in the as institutions and companies. Then you heard also to talk about the space innovation ecosystem in Azores. There are several dimensions: access to space with a small spaceport, small transportation to. We will be involved in the new reusable vehicle from HISA, which call it Space Rider. So the landing site will be Santa Maria. There will be some processing facilities, also some operations from the from Santa Maria, promote the Santa Maria Gateway communication to assess the space, in particular to some infrastructures that we will start to implement this year, so increasing what they already have there, and of course related with also to the rockets, the test engine facilities. Of course, we should continue the capacity building, so the programmatic challenge in HISA and this particular space and national space programs that we are promoting, and we cannot forget the some scientific and research for space science. This is one also of our targets. How to do it? So one of the key issue here is to articulating the funding, the funds that will be available in there are our national funds that we are participating in several international organizations. I mean, for example, HISA, but other organizations. But also one of the main targets is this challenge will create an industrial agenda for space. With a large system integrator. So this is one of our ambition, and the way to do it is to include space in the National Recovery and Resilience Plan. This is one of our target, and the country will have what we call mobilized agenda for for space. Let's talk about roughly and briefly about the digital planet. Is to tackle the problem about the data, high resolution data, to better understand our interactions between climate, oceans, atmosphere, and this is more related to the scientific community, but we will have also here one commercial and exploitation opportunity for the very high resolution data. We will tackle this opportunity, and I will show you that in the Atlantic Constellation we are promoting a very high resolution optical satellites constellation. I will show you later. And that, but particular for the digital planet is the challenge of the data policy. We need to have we need to assure to access to the data in the removing the barriers, in particular the costs and when we need to have the data. This is one of the main issues that we want to tackle this problem, because at the end is what we call the national data policy. And we are leading this discussion in Europe, and we are in the presence of the Council of the European Union. We are promoting this particular in the extension of the Copernicus, of the next generation of Earth observation high resolution data available to the society. And this is Earth observation for Portugal. Then, so at the end, this is a big platform that we want to concentrate all the data coming from Earth observation satellites, in particular to tackle some problems like land registry, fires, and to create a really near real-time operations for fires and monitoring our BMS. This is something that we are now involved in some working groups to provide solutions, and one of the solutions is to create this open platform. And the Atlantic Constellation. The Atlantic Constellation is framed by the Portuguese Space Agency. Of course, we are starting to studies using our program in HISA, what we call it Incubed. And then it is a cooperative federated satellites constellation. That means there are other countries that will join us in this satellite constellation. But there are two different satellites split in two different orbits. 16 CubeSat satellites. This is a 20 kilo satellites in 4 orbital planes to have a resolution, a time resolution around 3 hours. And I will explain better later. And 3 very high resolution in one orbital plane. Very high resolution, that means we are talking about 35 centimeters optical resolution on the ground. Then what we want is to create high resolution space and time, and also to scientific data to feed in that digital planets. And of course, one of the main focus will be in Atlantic. This is the baseline. So the payload is perspectral sensors, GNSS, AES, and of course we will address, and this is one of the things that we want to involve the community. We are almost close to start this discussion with the community. I announced this in advance. The Internet of the Things with the 5G protocol, this is something that I want that you be really involved on this. And this is a small satellite in a cooperative way, as I said. We will have the opportunity to develop some optical communications here, modules. And one of the things that we want to do is to promote the optical beamforming and the optical ground stations also for the two set of satellite constellations that we are promoting here. So this is also an opportunity to this industry and also the institutions, in particular IT, to be involved and particularly here also in the quantum communications, to really be involved as a big work package to this constellation. So itself, the very high resolution satellite, very high resolution constellation composed by 3 satellites in the orbital plane. 420, we can assure around 40 centimeters, 38 centimeters if we put in orbit 420 kilometers. So there are, of course, several bands. We are talking about now a medium satellite, so in the class, probably class 2 or 3 satellites, which is a platform 60 to 80 kilograms. Of course, with the optical communications, this is one of our targets, and with the very precise attitude control system, which and also the position and the boosting. So this is one of our main targets that we want to promote, and we already start with the studies, and we'll to implement at the end of this year. So we are now promoting the organizational, the industrial organization to set up the companies, the main contractors, and the external companies to implement this. So then other aspects, I will not address this deeply like I did for the other topics. This is mainly to promote the research and development and investigation, in particular with 5G to address the Internet of the Things, but particularly this is to attract some companies. They are ready. I had a meeting this morning with a company that is interested to come to Portugal. They will fly the first satellite in 1 month, and to address exactly these capabilities, and we want that they operate from here, from Portugal. And the space innovation hub in Santa Maria. You heard about the initiatives. I'm talking about now the European initiatives to locate the spaceports in Europe, which is the new space generation spaceports. And it is a low-cost, cost-effective new generation of rockets. There are several initiatives in the range, Swedish and also Norway and Scotland, and of course Santa Maria. And this is to complement the Kourou spaceport. Is not competing, but what we are talking about is I give you an example, the Rocket Lab launch pad. This is similar that we are promoting to install in Santa Maria. I can tell you that this will be probably very good news that we will receive in upcoming months, because the process is almost concluded, and will be selected one company to operate and build and operate the spaceport. And if you look to the right, you see why we are the best location in Europe. I should say the best location in Europe, because we have a free corridor to the south, and you know, when we are launching rockets, we are in really safety constraints. Now, this is really a best position, more because we have a teleport in Santa Maria with some capabilities that could be used. They are an extension of the capabilities. You can see in the right, in the top-down right picture, this is the teleport of Santa Maria with many or several terminals, and we can see the 50 meters antenna that belongs to the Portuguese Space Agency, and will be part of this engaged on this project also. And then we have the space rider landing approach and the constructing processing facilities. We have several dimensions. We have companies working in the payload, the vehicle, and also the processing facilities in Santa Maria. So this will be one of the dimensions of the space ecosystem. Of course, we are continue to promote the development of capabilities, and you address the SCA, but there are other scientific organization that we as a space agency, we are participating to try to organize the interests, industrial and scientific interests in Portugal. Of course, we will continue to promote scientific space research activities, space exploration, space medicine, robotics. We are creating a division in a unity, functional unity in the agency to tackle the observatories like SCA and ESO, and of course also the European Solar Telescope. Is upcoming project is coming. And we launched this year the first competition, what we call the Moonshot Challenge. It was a Research Award Alpha Million. It was a team from MIT that won this competition, and they will implement this solution to tracking plastics litter in the maritime litter in the oceans using artificial intelligence and also big data sets from satellites. And one of the things that we are also in a programmatic we are giving programmatic importance. It is the space debris. We are together in his. We are participating in the Clear Space. In the others, which is a Clear Space, a company that together with our industry, we want. A mission to remove, this is experimental, of course, to remove space debris. So this is a continued project we should continue to participate. It's a 7 million contract for Portuguese companies. And of course, education. If you see, this is a video. I don't know if this will be played. We promote the first competition of rocket competition in Europe. It was last October. They participate 12 university student teams from different countries, European countries. Today, we already launched the competition. We have 20 teams competing. I will put here, this is my last slide. I will put a small video to give you an idea what we are doing, in particular, what we want to promote as a nation, because we want that Portugal becomes the mecca of the rocketry competition. We will increase this competition, and probably in 2 years, we'll open this competition to the world. This is, let's say, not a copy, but to reinforce our interests to Portugal and Europe have this kind of competition. It was the first one organized in Europe. And this year will be in October, I think on the 3rd week of October. We are talking about rockets about 10 kilometers high, quite expressive. And the good thing, we are promoting our universities, Portuguese universities, Covilhã, Porto, Aveiro, and here in Lisbon to participate in this great challenge to Portugal and to Europe. This is European rocket competition. So I finish here, Nuno. This is my contribution. I hope that I didn't speak too much. Forgive me for that, but I will be here to answer some question if you think it is.
Okay. Thank you very much. First of all, thank you very much for accepting to be here today. It's a pleasure to have you here and to hear all these amazing ideas and opportunities for students, as we saw now, and also for researchers and professors. And I think it's a very good environment to join our activities together. So now I'm going for the second speaker of today, which is Arlindo. Arlindo Marques comes from EFASEC. So Arlindo, when you want, do you want to share your screen?
Yes, no. Can you hear me?
Yeah, we can hear you well.
I can say also, Nuno, that IFASEC is quite involved also in this initiative. So this is to leave the word to
yes. Yes, Ricardo, I'm aware of that.
I know.
I have some challenge on the topic. First of all, I want to thank you to CONFTELE for the invitation for this on this conference. I think this space would be in the next 10, 20 years one of the best parts in technical engineering in Portugal, and I hope we can contribute for the growing of the activity in Portugal and successfully, hopefully. On IFASEC, we have started the space activity almost 20 years ago, basically following the entrance of Portugal in the European Space Agency in the first years, and we were more or less invited to do some small activities at that time, and we start the space division in IFASEC. From the beginning, IFASEC was mainly focused on developing full units, hardware payloads for space, from its design to its final delivery, qualified unit for space. This has been one of the guidelines on IFASEC up to now. Nevertheless, the long duration of these projects and all the efforts associated to them. The space segment up to a few years ago and even in current days are a segment of market more or less closed, small, where everyone knows, and we hear lots of time claiming heritage to go in the projects and to go in certain directions of interest to develop hardware, mainly hardware for space. And basically our market segment in these 20 years have been, I would say 80% or 90% of it growth is ITTs, invitation to tenders, or in some cases, and now that we are gaining some experience and some visibility, international visibility, we are already start getting some direct negotiations with large integrators where we can gain some projects. We have contributed for a few missions up to now with our equipment. We have hardware fly in space. We have hardware in space currently and preparing to fly. Hopefully, we can continue with this in the next years. So, as I said, space started in IFASEC around 20 years ago. It started with a small instrument that was called EUTEMP, that was on board of International Space Agency, ESS, and its goal was during the critical phase of the migration of the Columbus Science Laboratory from ESA, from the spacecraft to the ESS, where it's not powered at that moment, and they want to monitor all the temperatures and all the environments on it. So this was the first step on IFASEC, of IFASEC in space, and we are lucky because this was a short mission duration, and at the end we were one of the few companies that can say that we get back the flight hardware to our facilities, and so we have it with us at IFASEC. Following EUTEMP, we have another project that was the AlphaSat that is on board of Inmarsat communication satellite, and this TDP-8 was a technology payload demonstrator or demonstrator payload that was composed by the two instruments, the MFS radiation monitor and the CTTV, the component technology testbed. Basically, the radiation monitor, I will talk later, it's one of our main lines of development in IFASEC. The CTTV was a component technology testbed that allows us to create a kind of TPU for space which control three different experiences, flying experience in space. One based in the GAN oscillators, another just to test the behavior of flash memories in space, and the third one just testing optical links in space. This is crucial for the space because, as we know, radiation is one of the most critical aspects when we go to the space, and the radiation exposition leads to a degradation of performance quite fast of the component and its behavior. So since when we send to space hardware and missions, they take years to conclude, and we don't want to have fails, otherwise the cost of this mission is expense is large, and the cost will bring to other difficulties, and we cannot fly hardware that it's not proved or it shall have high reliability to not having failings during the mission. After a few years and developing this radiation monitor for the TDP-8 mission, we start developing other radiation monitors for other missions that follows AlphaSat mission, namely the PERM for Pepiculon that is currently flying hardware, and now RADEM that we are concluding to fly to Jupiter in JUICE mission. Indeed, these radiation monitors, when we start first one, there are only another company in Europe developing radiation monitors, and currently IFASEC and this other company are the only ones playing or developing hardware in this field. These instruments are crucial for all the large missions and the outer missions foreseen in space, not so critical for CubeSats and satellites that has a short lifetime, but for outer missions, they are quite important equipments. IFASEC has also developed in the last years technology in the planetary altimeters, either LiDAR, either radar technology in these areas. When we start studying and developing the first breadboardings and engineering models, we were the only European company developing this type of hardware for space. And following this developments and breadboardings and all the test campaigns that we carried out. We are now developing the first flight unit aiming the plat mission for the asteroid landing. We launch in 2024. In between these major lines that we have been focused our activity in last years, we have developed other hardwares for space market and space business. This is a consequence of the know-how that we are developing and profiting all the technology that we have in electronics and proved hardware. So beyond those equipments, we have developed also for the Swiss mission the health monitoring hardware that will keep monitoring the solar panels of the Swiss mission, and also feeding its cameras. We have developed also for JUICE in the grand segment the unit test of the power control and distribution unit of the satellite. And we have developed under FP7 program also the GANSAT project together with a large number of companies, including a few in Portuguese. This project that was trying to push the GaN transistors to the space market, namely for the direct transmission and reception due to its known behavior of having large powers available with lower consumption and lower heating. That is also one of the major drawbacks of operating in space. So in these almost 20 years of space, IFASEC has developed several equipments that some of them have already fly, others are preparing to fly. But here you can see a bit our history in space, where we have our first equipment flying in 2008, the OTEMP, and then a few other equipments flying the PERM radiation monitor to on Bepiclone mission. The GANSAT was not flying, but it was just a science project. The altimeters from the breadboard now to the PALT mission. Sorry, it's a typo here. It's not PALT, it's a PLAT mission. Flying in 2024. The MFS and CTTV that are part of the TAP8 flying 2013. And to be launched next year, the HAVEN, the generation of the radiation monitor and the GMU. So this is a bit our experience. There were other activities, smaller ones, studies and so on, but I won't talk much on them. So following what we have done in the past and what we foreseen currently in Portugal is for the future. IFASEC is trying to move a bit his current business model to not develop just single units as we have done up to now, because these units that I talk are mainly focused for space missions, for large missions, where we have to adapt every time the equipment for its requirements, for its environment, and so on. So nevertheless, we are in the third generation of the radiation monitors. None of them are equal. So we use the know-how, but they are all different in the field of the implementation. And we would like to move a bit in direction of creating recurrent products in order to reduce the engineering costs and the time for the production of these equipments. So having this in mind and looking to the current missions that we are talking, namely from the European Space Agency, there are a lot of new opportunities in the space market that are appearing at the moment. Space weather and observation is one of the biggest or the big segments now growing, and here we will like to point at a new set of sensors at low cost, because I will explain it later, but a new type of sensors are needed here, and we show as Portuguese industry, and not only FASEC, but all the Portuguese companies and all the speeders will have to develop these new sensors. So we shall try to identify the ones that we have most knowledge and to bid for them and try to be the first ones going on that directions to gain the market. These sensors shall be at low cost, because for space weather and Earth observation, the direction that we are seeing in the market is to go on the on the small satellites, orbital, optical orbits or low orbits with low lifetime. So for this to be possible, and also to increase the number of satellites doing this Earth observation, space weather coverage, we want to have a large number of satellites. So we have to go for low-cost satellites, low-cost sensors. And this would be a migration of the current ones. So we shall bid for them and identify which ones are the most profitable for the Portuguese industry and for us also. Beyond that, we are also looking for other missions like Lagrange mission, where we know they require a radiation monitor. We will try to bid for it also. On the planetary and asteroid missions, surely we will be there looking opportunities for the altimeters. Another possibility, another mission that we are looking and checking is the SciLight mission. Here, and profiting the know-how that the Portuguese science community have on beamforming LiDAR, it could be an opportunity to bid for this type of technology for SciLight missions, beamforming LiDAR. On new space, this is another of the large missions that is foreseen now. There will be a huge number of opportunities on either in the upstreaming, either in downstreaming of services. And here, I believe that the Portuguese industry in space shall join together to try to push as much as possible these opportunities and this know-how to Portugal. And conclude this, I would like to highlight the Portuguese Atlantic constellation as, I would say, a crucial start point for the Portuguese growing of the space industry. We shall profit the Atlantic constellation not only to Portuguese interests, and obviously it has to be first on this direction, and as it is defined to observe the Atlantic, monitor the Atlantic, and also other Portuguese coverage, but we shall try to use also Atlantic constellation to acquire experience and heritage in the current forbidden areas for Portuguese industry in space, because as we all know, one of the most critical parts in space industry is to acquire experience and claim heritage on flying hardware on the critical areas. And we shall profit this Atlantic constellation to acquire those heritage and explore those areas. Also, we shall profit the Atlantic constellation to test and demonstrate the emerging technologies, like we talked this afternoon on 5G, IoT, all the other technologies that is emerging, informing. Why not consider not in all the Atlantic constellation satellites, but in some of them to have possibility of having an extra payload, just to try to serving as a tester of these technologies and to gain experience and heritage on these fields. So it is our view that we shall profit this opportunity of the Atlantic constellation, not only to build what is defined and established by the Atlantic constellation definition, but also to enhance it as a warm-up for other areas and other technologies to evolve the Portuguese industry in space. So with this view of future, I'm closing now my presentation. I will be here available for questions and answers if you have it. Thank you.
Okay. Thank you very much, Arlindo. It's a pleasure also to have you here. Arlindo was also a former student of IT in several years ago.
Yes.
So,
indeed, sorry, just 1 minute more. Indeed, I didn't say nothing, but indeed, Carlos Fernandes from IST was my my argument master degree when I was in Aveiro University. So I know it quite well also, as Ricardo said, and also know Carlos Solemo quite well.
Yes, and thanks, and also to have EFASEC here to give a snapshot of what was done and what is going to be done in the future. Thank you very much. So now I'm going to move to Ricardo Correia. Ricardo Correia actually comes from Sinuta. Sinuta is a very new company working on new space. So it will be nice to have also the view of Sinuta here today. So Arlindo, can you stop sharing so Ricardo can also share?
Yeah. Okay, let me try to. Okay, can you see the presenter view, right? Can't hear you?
Yes. We are seeing the Sinuta logo. Yeah.
Okay, perfect. So first of all, thank you very much for inviting me and of course Sinuta to be here today. to have the opportunity of show some of our developments and some of our products, and so that we can talk about just a little bit of Sinuta, so that everyone can know Sinuta. Of course, I want to greet all the participants on this panel. It's a pleasure to be here in this very good panel, and of course to greet all the audience. So in this presentation, I will briefly show some contents or some products and some products that have been developed from the Sinuta. I will show the Sinuta group, which has more than one company, so that you can understand the dimension of the company. And then, of course, I will show some of our thoughts in the new space and new developments, where the market goes, and some of our ongoing projects that will fulfill these new requirements from these new developments that are being made in the new space, let's say. So first of all, okay, so about Sinuta, we have more than 25 years of experience in the telecommunications sector, and we are one of the leading manufacturers providing the operators, distributors, and integrators worldwide. We have the Sinuta company, which produces satellite dishes from 1995. We have the Forsat, which is a company of trading of telecommunications equipment. Then we have the Sinuta Brazil, which is related, of course, also with the satellite dishes. Then we have Sinuta FCE, which is a company for cutting and stamping dies. And then the HCareSol, which is a company from 2015, which is sells and develops clinical and geriatric equipment. Well, I'm from Sinuta, the first Sinuta that you see here from 1995. And this is related with only Sinuta. Our production capacity, we are leaders in Europe in terms of capacity or production capacity per year. So we have the capacity of produce 13,000 dishes per day. We have more than 400 containers shipped per day, and these are some revenues in 2020, around 17 million euros. In Sinuta, we are around 140 employees. Well, so our evolution and where do we want, or where do we envision to go in the next few years? So we started with the DTH, the direct worm antennas, then some certifications, of course, the very small aperture terminal antennas. Then we begin to produce some of network systems, racks and sub-racks for optical fibers, and some certifications also. And then what we expect or we want is that in 2023, we could begin the production of the phased array antennas that I will show briefly in the end. Some of our products portfolio, of course, satellite dishes, DTH and VSATs, LNBs, bucks, cables, racks, and accessories. So this is just to show what is our product portfolio. Well, in terms of our main markets, we are in America, Central America, South America, in Europe, and in a difficult market, which is in Africa, but we are there also. Some of our main customers I present here today, just so that we can have more or less an idea, but we are talking about, and these are some of them, Eutelsat, Orange, Telefonica, Sky, and we have a lot more than this, of course. As we are investing in the research and we want to invest more on the research, it's important to be associated in different associations. So we collaborate with the main Portuguese business association for the promotion of business innovation and technological cooperation from COTEC. And of course, it is important to be seen in the Portuguese space ecosystem. And so we belong now to the space catalog industry from Portugal Space also. Well, this leads me to the presentation that I I want, or some thoughts that I want to address here today. So how's the satellite industry of today? If we think on the geo satellites, or how this is done. So we have the ground segment, we have the space segment. So we have the fixed terminals that point to geo satellites with large and shaped beams. And yes, it's fixed, and our business is done. So if we start to think, for instance, in 3 million subscribers, and if we want to change the terminal 2 degrees to the right, and if we want to do this like every 3 minutes or every 2 minutes, well, that's unfeasible. And that's where the new space is going, of course, talking not in GEO, but LEO and MEO. And so I bring this slide here, which refers to new developments. In one case, the new launchers, that what we'll do is to reduce the cost to orbit. So for instance, the SpaceX that we know, they use the rockets. They are relaunching the rockets, which will reduce the launch cost. And by reducing this launch cost, will allow more satellites to be launched, which will enable these new mega constellations of hundreds of satellites in MEO and LEO. In the other side, we have the HTS, which are the high throughput satellites that will change a little the paradigm of these satellites. So in the traditional satellite, we have a single large beam and frequency reuse between the satellites. And in the HTS, what we'll have is that they will increase the global capacity for the communication. And by increasing this, they increase the total communications capacity of, for instance, a single vehicle. But we can think this on different beams that it will enable to produce different beams, for instance, for an urban area, for a rural area, or a remote area, or even for different applications inside the same area. Now, this is where it goes. Well, other thing is the new constellations, and we hear every day, or not every day, but every week or every month, we hear about the new constellations. This week, we heard about the Telesat with the Thales Alenia Space, that they are developing around 290 satellites, which they call the constellation, which is the Lightspeed. Then we have the well-known Starlink that is already launching a lot of satellites. We had some time ago OneWeb entered on bankruptcy, then now they are back again. But yes, we can see the Amazon Kuiper, we will have a lot of new constellations, and so we will have a lot of new satellites, which means these and all of these industry improvements will place, of course, new demands on ground technology. And that's our segment, and that's our focus in terms of Sinuta. So we will have more satellites, more spectrum, and spectral reuse. Of course, this will lead to LEO, MEO will have significantly lower latencies. That's what has been told, and higher bandwidth, which means cheaper capacity. So the price of megahertz will decrease, of course, which means more users. And of course, the benefits of this space segment has no value without the users, which means they need to communicate with space. Well, we have now some Starlink terminals right now, which they are on the Ku band for different distances and so on. But we need some kind of new products and some kind of new innovation in terms of these terminals, because what we have besides that is the expensive mechanically steered antennas. And so, as with all of these new innovations, much better circuitry, much more satellites, and so on, which means the developments of the multi-orbit, the HTS that I referred, the 5G innovation and millimeter waves that we see and saw on this conference also, the reusable launch vehicles, and the advanced in this modulation and chipsets for the new modems, or for the modulation and demodulation of the signals from the satellites. Well, we have to look on the other side, which is the challenges in terms of ground antennas, and what is the main problem. So they require high power, they are mostly spectrally inefficient, and in a lot of cases they are very limited in bandwidth, especially in the new requirements of these new LEO constellations. And most important, I guess, it is the lack of scalability. Well, again, this leads us to the known phased arrays that have been used for SATCOM for many years. They are very good because they have low profile and reduced weight, and are very important for the aircraft segment, of course. But just quickly, if we look into and if we increase the number of elements of these antennas, well, the cost, the heat, and power consumption will, of course, all be driven from this number of elements. And in some cases, in the Ku band phased arrays, where we want to have a lot of and thousands of elements, often the costs come greater than 50K euros. Of course, this is reducing because the silicon generation is increasing and so on. But yeah, that's also a problem. And if we want to multiply the beams per terminal, we will need to double, in some cases, the number of circuits. Here I present just a few slides, just to show what's the market size versus the antenna throughput, and in terms of unit costs, so that we can have more or less an idea where we have more markets and what's the costs of it. So if we look into the commercial airplanes, we have high bandwidth, but the costs are very high, and the market is not so great. Of course, it is in terms of money. Of course, it is, but that's other way. And in terms of cars, we have a lot of market size and with low bandwidth, and the costs will decrease a lot. So just quickly to show the analog phase shifting, and I want to enter here in details, is just to show that the analog phase shifting is very good, for instance, for small antennas and for low bandwidth. But we envision an ideal antenna which goes into the digital domain to perform the digital beamforming from the true time delay. If you control each of these elements that you see on the antenna, you can avoid some of the known problems, for instance, in the analog phase shifting, which is the beam squint, which is the beam angle changing as function of the frequency. Well, and in the digital domain, you can control each of the elements, and you can focus your beam in different frequencies with the same angle. And that's another point in favor. Well, looking into the analog phase shifting, and if we start to increase the beams, as you all know, yes, of course, we will increase the cost, the power, and the weight. So this leads me to a problem that exists, but leads me to the solution that is the project that Professor Nuno told us at the beginning. Well, this is a consortium formed by Sinuta, Instituto de Telecomunicações, and Inestec. This is more or less the block diagram, superficial or general block diagram that we have for the project. And mainly the antenna elements and the RF front end that you see is being developed from Instituto de Telecomunicações. So they need to develop new architectures to connect antenna RF front end with a compact structure, new topologies of the radiating elements, and the developments in the Ka band in two different versions, the discrete and the MMIC. And we will follow the gallium arsenide technology. And in the other way, we have the FPGA digital beamforming, and we have the analog digital and digital to analog conversion chain to allow the interface between the digital beamformer and the analog front end, which the Inestec will be responsible on. And most important of this needs to be scalable. Why? Because one of the objectives of this project is, of course, to build a prototype of 16 elements for a transmitter and 16 elements for a receiver. And if we want to increase this, for instance, it must be possible to increase this from a 16 to a 64, to 166, 56, and so on till, for instance, 4,096 elements. Well, this will lead us to hopefully with this very good product that will be a terminal that can be scalable to any size depending on the customer needs, of course, and what type of constellations do we need to communicate. Any number of beams, low power consumption, of course, depending on the advancements of the silicon generation, but we know that they are advancements, and low weight due to the flat panel array. So I don't know if I shared my my sound, because I will finish with just a presentation of Sinuta, just to show you the inside our facilities, how it is Sinuta. Hopefully you will hear. Oops, sorry. Can you hear? No. It has some subtitles, no problem. This is just to show how it's inside the company and the machines that we use and the tools. And so this concludes. Sorry, it was, I thought it had sound, but okay, no problem. Thank you.
Thank you very much, Ricardo. And again, it was a pleasure to have you here, and also Sinuta to present the work. And for those attending, Ricardo was also a former student of IT, so that's
very recent.
Yeah,
very recent.
So now we will move to Rodolfo. I think Rodolfo is online. Rodolfo?
Yes, I can hear.
Yes.
Can you hear me?
Good. Yes, we can hear you. Can you share the slides, or do you want me to share it?
No, I can share. I can share.
Okay, good.
Just
Rodolfo
to notice
Martins,
yeah. Go on.
No, I was saying that Rodolfo Martins is from Evoleo Technologies, and he will make also a brief presentation of Evoleo activities in space. So feel free, Rodolfo.
Okay. Well, first of all, thank you, Professor Nunebosch, for the invitation. You know, from the video, confinement situation, end up in the middle of a train with a mask on. So I will, let's say, switch off the video, and I hope that you can really can listen properly what I'm saying. But that's how it is. So just to save a bit of bandwidth, if I may, just to turn off the video. So I think you can see.
Yes, we are seeing the
Can you see
slides.
the screen? You can see the screen. Okay,
yes, yes,
so
yes,
we
yes,
start
yes.
like this. Let me full screen.
Yes.
Okay, so
Yeah.
I'm going to be quite focused, and it's quite simple presentation. So we'll talk about our experience we have with onboard computing, what is our experience in the past, our heritage, and what are the insights that we'd like to share with you regarding our activities and our perspective of onboard computers and avionics. So Evoleo was founded in 2007, so 14 years ago. We are specialists in embedded and computational solutions. So basically what we build for space is computer units, onboard computers. And we, since the beginning, we specialize in electronics development. I think I can, okay, in electronics development. We are a small company. We are around 25 people in Maya, in Porto. And we've started a second company in Munich roughly 3 years ago. Again, the focus is in computational solutions, electronics for space, but now targeting LEO instead of more traditional electronics for space, rather hard. So ultimately, Evoleo as a group is still a small group, and in space we really completely focus on electronics. Onboard electronics. So we don't have only space, we also have 2 additional areas of activities. So in terms of capacity to be systems integrator, we can be a complete system integrator in the industrial activities. What we do for industry, basically build test machines, as I say, ugly fridges for quality departments and for production line testing. For railways, we design, build, and install monitoring systems and monitoring subsystems for the infrastructure. And in space, the main topic of this conversation, again, we design and implement reliable electronics, again, focusing on embedded systems. By the way, feel free to interrupt me anytime. I hope that you can still hear me, right?
Yes, we are.
Yes,
we are hearing.
I'll be pinging just in case, because.
No, no problem.
Okay. Sorry. Okay, so we have several references from since the very beginning, and I'd like also to share with you what are our key areas of expertise. So this is a slide where it shows briefly our key references for space. So starting from the left side with the TRL-9. We heard from Arlindo talking about TDP-8. In fact, we were partners in this project almost 12 years ago. Our key contribution was, in fact, to the onboard computer, the onboard software and power distribution unit, and this is a success story for both FASEC and Evoleo. Since then, we have participated in other activities, most of them related to onboard computer, the power distribution unit, onboard software, so one way or the other related to computational solutions, either for International Space Station, for launchers, for Ariane 5 and the future Ariane 6. We have already provided units, and then a second and third generations of our own onboard computer. This ALTB and PVSA are kind of an evolution from the original TDP-8 onboard computer. And what we see on the right side is what we call CHICS, the Cod Space Highly Integrated Computer System, and the Project Plane, which is supported by the P2020 funding, co-funding activities. Is basically our interpretation of a new space onboard computer. IT, Institute of Technologies, and Professor Nunovors are cooperating with us precisely in this project. One that is not completely aligned with onboard computer is for Plato. It's a traditional, old-fashioned space development, but we are in charge of the digital controller. So it's a different flavor of flight onboard computing. Of course, the level of TRL is slightly different. Our main reference still remains with GDP8, but as Alindo said, now Alindo, I'm stealing a bit of your words, but it's really not easy to get heritage, and especially when we're dealing with a specific piece of technology. And if you want to target the old sharks and old habits, it's really not easy to enter. That's why we had also to shift our strategy. Well, then comes the question: what is the current status of avionics and computing for small satellites? Of course, we as a small company cannot aim to large satellites. So let's try to understand what's going on with small satellites and what is usually requested or aimed for avionics. So usually the avionics for small satellites, they have to deal with the attitude control interface and processing, commanding the difference of systems, payloads, reconfiguration, data telemetry, data encoding, and also the power distribution unit. It seems a lot, and that's precisely the problem, because they have to have separate units, one per each function. And of course, they are well behind in terms of technology compared to commercial solutions, because this is a quite old-fashioned area of activity, as a quite old-fashioned industry, and novelty is usually not seen with good eyes. So what is the cost of existing avionics? Literally millions of euros if we really want reliability. So the typical old space legacy. And of course, it's somehow understandable, because one GEO satellite can easily cost 400 million. And we can't just go there and, if something goes wrong with a pickup truck and let's say, and do maintenance, this is not possible. So reliability is a must. However, on the other extreme, on the other side, we have the CubeSats. Quite easy access to space, just a few thousand of euros, like 50K, including launch. But are they reliable? Really not really. So there's a lot to do in between. And why all this big gap? First, space is really not easy. Qualified components are definitely expensive and not available, apart from the fact that most of the key suppliers in the US, which is it's a problem in terms of double usage, in terms of access to those materials, and COTS components that are not taken into account for reliable design, they fail. So no one really trusts a commercial component if you really want a reliable mission. And also, the last but really not the least, if we knock the door with novelty to let's say to an old project manager, usually they say, well, this is just the way things have been done for many years, and we are not willing to change. We are not willing to take the risk, because taking risks, they can become really expensive. So what is then, in a nutshell, the basic difference between the legacy old space, really big boxes with lots of expensive and bulky boards? They are quite heavy, which is also a problem for launchers, old technology, and they are quite slow. It's incomparable to the onboard capability that we have on a old space avionics compared to our own mobile phone. Our mobile SATs, multi-unit, but not reliable, no redundancies. They're really definitely underpowered, especially when it comes to telecom. They're not qualified, or sometimes they are not even qualifiable. And in terms of structural cases, they are not prepared for that. They are just basically to be integrated as Lego, again with pros and cons. No reliability, but very simple, very easy to make, to build, and to launch. So, what is again, in our understanding, in our approach to the market, what is the market feeling? So, what basically customers would like to have? That's ideal world, of course. So what should avionics for small satellites do? Again, all the functions are essential. They have to be done, no other way. So we can't just avoid them. But how should they do it? And we, not just us, of course, but the key conclusion is we have to integrate as much as possible in the smallest, lowest power and the lightest unit possible. So high integration is the key to fulfill the gap between the unreliable CubeSats, but cheap, and the very expensive and reliable old-fashioned, old space solutions. So on the other hand, how well should they do it? So what are we looking for with this high integration? As usual, we all want the best with zero cost. So as much processing power as possible, as much storage capacity, of course, to try to ensure a reliable and fast communication. And this is not just a wish, because it's fundamental. Otherwise, we might lose the mission. Reliable storage of sensitive data, especially if we are thinking on the satellite as a whole. We don't want to lose. When we reboot, if there's a problem because of radiation, we really want to keep going where we stayed, where we left before. So we have to have the satellite under control all the time. Then the question of availability. If we really want this kind of satellites and to use cheaper solutions, in the end, the customer, the operations, they want the units there. This is not just a luxury. So it has to be available, especially for telecom, and preferably that we don't require satellite platforms or integrators to change dramatically. So it's not a good idea to change avionics, and then the typical integrators, typical satellite platform developers, they have to change everything. They have to redo everything. This won't work. Then the question of cost comes in. How much for all these functions? And then, of course, 100,000, between 100 and 200,000, this was the magic number that everybody is looking at. It's okay, it's a price of a house, price of expensive car, but still much cheaper than the 3 to 6 millions that the typical avionics cost. So why? Well, on one side, processing power extends use case for small satellites. So if we have something that is really powerful in terms of capacity, well, the imagination becomes the limit to what it can be done on board. Also, less downtime and more lifetime increases the return on investment. So from a customer perspective, what was limited to reliable satellites now becomes or can become feasible with cheaper satellites, small satellites. Also, reliability reduces space debris and overall project risk. I'm sorry, just a second. Can you still hear me even with someone talking background?
We can hear you. We can continue.
Okay, so as still on this slide, so missions are again from the customer and the market feeling. Missions are cost, mass, and power limited, but no one, and literally no one, wants to give up reliability and availability. Otherwise, it's useless, and we are just playing around. So, what is our evaluable approach to the solution? So, on one side, to incorporate as many functions as possible into a single, reliable, dependable, and performance unit. Of course, being cost-effective. Okay, this is not quite quantifiable at the moment, but we'll see in the next in a few tables ahead what we mean by this integration. So, how do we? How are we solving the problem? So, a combination between industrial technology, so military technology, so basically COTS technology, a combination between this non-qualified with other qualified components, intelligent mitigation techniques. So sometimes it's not a question of components, it's a question of how we use components. And of course, a special design targeting reliability and availability of the system as a whole. We don't really care if a component will fail, as long as we know how it will fail, and as long as we can recover from it. So how can and why can we do this? Well, now I'm selling, of course, that Evolevo is the best in the world, but anyway, we do have experience in design and integration of dependable onboard computers. We do have experience with automated test equipment. This sounds that has nothing to do with space, but it really does, because with test equipment, we always have to go around. We always have to identify where problems are in electronics. So we really can spin in this technology and this know-how to space. And of course, we have to work with partners. And in our approach for solution, we are teaming up with IT in Aveiro and with Airbus in Munich. So, and the last but not least, of course, we always need support from ESA. So those guys are definitely supporting this move forward. Okay, so a quick summary of the benefits of this integration. And we can see that having separate independent modules to answer specific functions on the avionics, it really brings the traditional solutions to be massive, both in power, in cost, in mass, and ultimately in size. But of course, there's an advantage on this. They are really targeted to GEO and to survive between 12 and 15 years in orbit. Okay, but this is the Rolls-Royce, and we don't want to buy the scooter. So our approach tries to be in between. So something that really makes sense for a typical LEO 5 years mission with a reasonable cost for a reliable solution, let's say around between 100 and 200 kilo euros, a reasonable power consumption, and a reliability or availability that is comparable as a system that is comparable to the GEO solutions. All of this at expenses only of using commercial off-the-shelf components with the extremely high processing capability and integration capability. So as a generic comparison between, again, the Rolls-Royce and the, let's call it scooter, although they are very nice scooters, we see that we are more or less in between when it comes to reliability and availability, definitely in the lower end when it comes to price. In terms of availability, we can be proud of what we can get using COTS. But in terms of performance, we can not just Evoleo, but a solution like this, we can be extremely, extremely ahead of anything that exists in the market or anything that exists in the traditional space. There's no comparison at all. And all of this with much fewer components than even using the complex legacy solutions. That's why this is opening amazing new possibilities for LEO solutions. So we started, in fact, 14 years ago with the traditional space. So the first generation from 2010 was based on the TTP-8. It was actually cooperation with FASEC. Was based on Leon 3, single core. Rad hard parts, really very expensive and quite slow implementation. But it was really reliable and it really works very, very nice. But then we have to evolve to a second generation because single core in 2010, when already multi-core solutions were available for mobile phones, again, the performance was really not that great. Then the second generation, we basically evolved, still sticking to rad hard parts, still sticking to being expensive and slow implementation. But now with the dual core, then we could play around with the onboard software in asymmetric multiprocessing. So opening again new frontiers in terms of how these units could be used. But still, we are on the wrong side of the team. So that's why the third generation, that's where we're putting the emphasis now, is on integrated avionics for LEO, using system on chip, COTS parts, extremely high performance, much fast time to market, and definitely a faster implementation. And again, as I mentioned, that's a strong cooperation between Evoleo, Airbus, and IT. And this really pays off because we have three main advantages and highlights. One, in terms of performance, we are talking about 6 CPUs, 2 FPGAs, multi-gigabit per second interfaces, downlink capabilities above 100 megabit per second. Actually, the existing systems, the GEO systems, for example, they don't even do it. I'm not talking about at the payload level. I'm talking about at the avionics level. And of course, in terms of mass and power, this is just a fraction of the traditional ones. Then the cost and benefits. We have COTS components. Cost is definitely smaller, and again, time to market, as I mentioned. And important topic, the industrial inspired implementation. We can see space equipment like an industrial development. But as long as we also put what is in the middle, and let's say an additional layer of good design, that's what we call supervisor, where we can deal autonomously with fault handling, supervise operations, and that allows us to increase the availability of the entire system and also to allow in-flight reconfiguration. So for constellations like, for example, the constellation that is being planned in Portugal and the multiple constellations that are being planned in Europe, these are the requirements, these are the wishes that people are really looking at. Okay, so and this is basically the last slide. What are the keynotes from our activities? And activities for integrated avionics. We focus on the design and development of platform for mini satellites, for small satellites, integrated. We tend to implement differentiated features and architectures and the characteristics at architecture level. Again, component is just a component. It's not what is the key goal. COTS components, and most importantly as well, agile processes, methods for development and production. We cannot afford to do things as old-fashioned. We can't. It's just a matter of survival as well. The last keynote is about common technology. So this high level of integration and high level of processing capabilities really allows us to use the same, pretty much, let's say, over 85% of the baseline architecture can be used for onboard computer, for software-defined radio, for attitudes or AOCS or attitude and termination control systems, and also for payload management. We're basically talking about the same key components, which integrate multiple CPUs, a couple of FPGAs, supervisor, an extreme capacity for performance. We can even run artificial intelligence algorithms in all this integrated architecture. And this is, again, to our perspective, the key to answer the market needs and to fulfill the gap between the cheap and unreliable CubeSats or CubeSat technologies and compared to the old-fashioned, reliable, expensive, traditional, and out of our league, basically out of our league technologies. Okay, and thank you for having this chance of sharing our insights. Feel free to contact me anytime.
Okay, thank you very much, Rodolfo, and thanks for sharing with us the activities of Evaleo. I think it's very profitable for everybody. So I know we are very late. I think we have a moment here for questions and answers. So if you have any questions, please put the questions. You can use the boxes, the chat boxes, the question and answer boxes. Feel free to do it. If not, I will kick off the question and answer. And my first question actually goes to everybody, but I will start with Ricardo. I saw that PT Space is looking to 5G IoT, business-to-business satellite communications. And I think that's a very important and hot topic for IT. So I will ask you if you can talk a little bit more about what are your expectations and what are your ideas for that.
Okay, thank you. The thing is, we have in front of us a big opportunity to cover the remote regions, right? And when we are talking about the Internet of the Things, in particular, when we are talking about to connect to several sensors and sharing big data, we cannot be concentrated in the big cities. So this comes with an opportunity with some ideas and also some missions they are preparing, some companies, to use the same protocols using 5G, but using satellites to extend capabilities, communication capabilities in the remote regions. And this is the idea that we want to promote. At the end, for example, if we look to our Atlantic area, I can tell, for example, now SpaceX is tackling this area particular because it's a big corridor for highways for the ships, no? And there are business opportunity. Probably you are not aware, but SpaceX is looking for some places to install the gateways to exactly to address this market. Okay, of course, in the future, these big constellations will address particular the gaps on the business that they don't have business now. They want to promote it. This is one of the reflections that we did internally to see if we can use, particularly in this promotion of this constellation that we are preparing, if also we can use this kind of technologies to complement the remote regions. But again, there are two dimensions. One is the development itself, and this is an opportunity with Atlantic Constellation, these capabilities. Another one is to try to understand what are the movements around Europe, in particular in Europe, to attract some companies. They already started, and there are some companies they already started to work on that, and there are some experiments that they are preparing to launch, particularly in the upcoming months, in March, I guess, and that will be also embark some quantum capabilities. And you remember, Nuno, we had this in conversation some months ago when I visited IIT, and there are some further evolutions. We want also, and this is another topic, we want also to reinforce our presence, in particular in the quantum communications. I already start to make the homework to address all the groups in Portugal, because we need to put some flagship projects to give more expression. And also, and this is one of the remarks that I want to leave here, this satellite constellation that we are promoting, in particular this agenda for space, the mobilizing agenda for space in the recovery plan, we are dedicating one work package really to the quantum communications and the optical communication, which is the future for the communications from the ground to space. And this is what we're going to do. And this is an opportunity to involve the groups that you are part of course, and so many other your colleagues. But it's an opportunity to develop some competences here in Portugal, and also to, I don't know if you are aware about what was discussed in the space conference 3 weeks ago in Brussels. I was there in a panel, and the Commissioner Breton just announced the program that Europe should be reinforced to fill the gap and the delay that we have compared particularly with China, and also some movements in the US. And we need to do it. We need to be part of this movement. The quantum communication infrastructures, you know what I'm talking about. This is something that we need to have a note here. For that, we need to have companies, institutions that are working or need to be working in this domain, and particularly if we are preparing a constellation, and if you are preparing a constellation, there are many dimensions. So the ground segment itself, and the space segment in the downstream application. But if we are preparing this at the national level, we cannot use the same technologies for the last 5 years, right? We need to think that, look, this is a program for 4 years. Okay, the satellite constellation will be ready if we launch this year, probably in 24, 25, it will be ready. At that time, we cannot, we should not be operating the S-band, probably there are some links in S-band, but we need to move forward. And this is some topics that I want to also to push, in particular for the beamforming. From and CNUTA is also, I know, probably you know, Ricardo, that we are trying to support you in a big program. The thing is, we need to look forward to the upcoming technologies and to put our teams in a different position. At the end, this is what we need to do, involving in our ecosystem, because we cannot prepare a constellation to put a traditional S-band, and you see. So I don't know if I answered your question, Nuno, but this is a broad opportunities that we our community should be. There will be some announcements very soon. We are preparing the agenda. It's quite early, but again, you saw this is a big ambition for the country, and
Yes,
this
for
is a
sure.
unique opportunity. The train is already. We are building the train. It's not passing, but we are building the train. Let's see if everybody can get the train.
Yeah, for sure. Thank you very much. I don't know if the others want to share something. Ricardo, you want to say something about 5G IoT, or Rodolfo?
It's a different area from what it interested me in terms of collaboration with IoT, but not as in CNUTA right now. We are looking into maybe different segments. But first of all, we want to develop, of course, the terminal, because it will be hard. It will be a hard mission, and we need some more investments to pass some of the phases that we will have. But then, of course, we will see. That's not mainly my area, I'm not a commercial or inside the commercial area. I'm more in the research side, but let's see what we will.
Ricardo, if you will be so well succeed in this optical beamforming, I really believe this is something that we need to push, because you can make some very strong partnerships, and this is the edge of the technology development,
sure.
right?
For
so
sure.
This is something that we need to push at the national level.
Yes, we were treating this. I don't know, maybe 1 hour before this conference starts. I was talking in another meeting about that. For sure.
Very good.
Yeah.
Yeah, I don't know if there are any other questions, or if the other members of the panel want to say something. Rodolfo?
Yeah, maybe I can share also some insights about the 5G. In fact, 5G on ground hasn't lifted off yet properly, but we can't forget space as having a key goal, a key role on 5G, and the possibilities, the digital capabilities are becoming real. And Professor, because we are cooperating in the same project for software-defined radio, where using or implementing 5G concepts, let's put it like this, it's something that we see that's possible, and it really opens significant opportunity to deal with massive data, massive onboard and downlink data without special analog electronics, and this is something that will be the future. So 5G is okay. It's a name. It's one type of technology, but this is really reaching the small satellites, and we have to live with that. Nonetheless, my comment on this is possible to achieve with, let's say, with reasonable costs in space. We can indeed be bold and trying to implement, in fact, these technologies, and even, of course, from Portugal, to embed 5G in our own constellation, for example, or in as a technology made in Portugal. And this is not just a wish. This is becoming a reality in the coming months.
Yes, for sure. I don't know if any other
No, let me just comment one thing which is important. We are living a moment that Europe is looking to space as to implement the harmonization technologies, but also the sovereignty of the Europe and the independence of Europe. And space start to appear in all the space, in all the resilience and the recovery plan. Don't be surprised if you heard that many European countries will propose constellations. Why? Because I had a very nice conversation with at the European level, about particularly the space program. One of the main problems is the European demand. We need to faster than the European demand. And this opportunity in the recovery plan and put many, for example, I heard that our neighbors, Spanish, they have a lot of proposals and constellations. Of course, this will be probably in 10 constellations, 2 will survive, like the launchers. There are many initiatives for launchers in Europe, for sure. There will be 2 players, roughly, because the business is not the launchers. The launchers is what we call the upstream. There are upstream, middle stream, and downstream. The upstream is not the business. I can tell you that this represents of the investment about or the growing market about 1%. And if you jump to the downstream, they are around 10%, 8-10%. So there are big difference. And then the thing is, when we are talking about, just to give you an idea to compare the costs, when we are talking about assess the space, for example, the new generations of rockets, particularly the Electron from Rocket Lab, you know, we are talking about 20,000 euros per kilo. Okay, to launch.
Yeah.
To launch. And you know what is the price of SpaceX? Is around 3,000 per kilo. What does it mean? Because why? And also the Russian, the Soyuz also. Why? Because the right share, there are capabilities to put some tones and so on. And in particular, this is a niche, and this is an opportunity for someone that wants to launch tomorrow. You see? This is, but there is no, there are some expectations, of course, but the market is not so big. So that means Europe need to stimulate the demand in the complete value chain, upstream, middle stream, and downstream. Itself, all the companies in space are positioned themselves in the downstream, because it's easy also to set up a company and to explore the opportunities, particularly, for example, the services and manufacturing equipment that some one of you that are involved. This is my last thoughts, and forgive me, these are quite late.
No,
and I need to go to the supermarket.
Yeah, exactly. That's that's challenging now. Yeah. So
this is a space challenge, exactly.
Exactly. Erlin, do you want to say something?
Okay, regarding the 5G, indeed, is not being at the moment dealt by Space Division at IFASEC. It's mainly addressed by the transportation segment at the moment, and there are other groups working on that topic. I believe they were also addressing this conference and this topic mainly in this topic. But yes, I agree with what was said. 5G will play a large role in the coming years. And why not also profiting to try and as Rodolfo said, with this, I would say low cost. Okay, it's not really low cost, but for space market, it's low cost processing capabilities that is developing. Why not exploring these new opportunities that will be for sure quite important in the coming years?
Yeah, for sure. Well, I see also that Professor Carlos Shalom and Professor Pedro Assunção has connected the videos. I think it's extremely late. And if there are no other questions, I would like to thank you again, all of you, for coming today. It was a very interesting afternoon. And I will give the word now back to the committee. Thank you very much for being here.
Thank you.
Thank you.
Thank you.
Okay, I think it's my turn. So I'm Pedro Assunção. I am the technical program chair of the conference, and I'm here to close the session with Professor Salema as well. So before closing, I'm going to share some slides just for these closing sessions. We are also going to announce the top 10% papers, the best papers, the best 10%, and the best paper award. And we, first of all, I also would like to thank everyone, especially the session chairs and all the people in the technical program committee, all the people that who contributed to this conference, because this is a joint work of many people, and there are also the staff that is behind the curtains, so you don't see them, but there are people just dealing with many problems or several problems that appear in real time, and they have to solve them. So let me try to yeah, this is I think this is it. Okay, I hope you can see my screen, and I think now it's full screen. So this is a closing session. Let me just give you some facts and figures. So we, as you already know, we have been fully virtual. So this conference was planned to be not virtual last year. Then we postponed it, trying to make a physical and live conference, and we could not do it due to the circumstances that we are living. So the conference altogether, we had a tutorials day. This tutorials day came just a few days or few weeks before the conference. It was not planned initially, but then this opportunity appeared, and we included the tutorials day. So before starting the conference, then we had two plenary talks with the distinguished lecturers and the high-profile speakers, Professor Mário Figueiredo and Professor Maria da Graça Carvalho. And then we had two panel discussions. In fact, we had one, because one of them was canceled just a few hours before it started, so we could not do anything about it. We were informed about this cancellation at lunchtime, and it was meant to start at 5 o'clock. So then we had 6 special sessions, 4 regular sessions, and overall, we had 72 papers presented in the conference. So the registered participants, just to give you some analytics coming from our website, we have participants not from all over the world, but okay, we have from some far places, from Canada to China to United States, Brazil, Europe. So, of course, most of our participants come from Portugal, 80%, but we also have around 20% of participants coming from other places. I'll show you some countries. Unique visitors 600, and we had also the special sessions. They were streamed live in YouTube. So and also these panels, and these numbers do not include the views of this panel, because I prepared these slides before starting this panel. So, but until the afternoon, we had 195 YouTube views, which is, I think, quite good. So all the other countries that visited our web page, so this 20%, we have here distribution, many from Spain, Brazil, United Kingdom, but then you have other countries. Okay, this is just interesting as statistics of the conference. It reached some countries outside Portugal, so it's quite interesting to see these numbers as well. So I don't want to take a lot of time, but I'm going to present now the top 10% best papers. Before presenting these top 10% best papers, I would like just to explain how were they selected. All the papers of the conference were reviewed by at least 2 independent reviewers, which means some of them or several of them had 3 reviews, and a few of them had 4 reviews, but all of them had at least 2 reviews. And we selected these top 10% best papers from those papers which received the highest scores from the reviewers. So this is let's say a numerical criterion. So the reviewers have different parameters to assess and to evaluate the paper, and they give a score, and in the end there's a formula to calculate an average score, and we took the 10% best scores of the papers. So these are the 10% best papers. If you count them, there are 8 papers, and you may be asking why 10% of 70 is 8. It was just because we had in fact 3 papers with the same score, so we included all the papers until to this last score, and this gave us this list of 10% the best papers. This list is ordered by alphabetic order of the first author, so doesn't have any rank here, and the authors of these papers are going to receive a certificate, and from the conference committee to in fact to confirm that they received this top 10% best papers award. Then we go to the best paper award. So the best paper award is sponsored by two companies, the OptiLink and Wavecom. So we are very happy to have these companies with us, and they sponsor the best paper award, which in fact has money. We have a prize and 5 digits, as you see here. And quite interesting. So and I'm going to show you the best paper, and you'll see these 5 digits. But of course, I would like to thank our sponsors, because it's very important, and it was only possible to give this prize money because we had these sponsors agreeing in paying, so the authors are going to receive the money. So I'm not going to make you wait a lot, so I'm going to show you the check with the money and the oops and my okay, and the best paper award goes to this paper, okay, Algorithm for State of Polarization Generation in Polarization Encoding Quantum Key Distribution, okay, and the paper is authored by Sara Montey, Mariana Ramos, Nuno Silva, Armando Pinto, and Nelson Muga. Okay, so this paper is among the list of 10 papers that I showed you before, and it was also recommended by the reviewers to receive an award. So 2 independent reviewers proposed this paper to get an award, and so the technical program chairs also decided then, after analyzing the paper, that this was the paper which deserved to be the best paper award. So this is the check that then we'll see how they receive, but €800. So this 5-digit number, it's a nice number anyway. So and now I would like to ask if any of the authors are here, especially first author. I think Sarah was the presenting author of this paper. I don't know if she's here. Okay, Sarah is here. Okay, you can say something at least. Okay, please.
Thank you. I'm very pleased for this prize. I wasn't expecting that, and yes, and I want to thank all the team that have made this possible. So I'm very happy.
Okay, thank you. Any other author wants to say anything? I don't know if it's present or not, but okay. Also, I'd like to just to point out that the first 2 authors of this paper are women. So IT is also discussing sometimes the question of gender balance and gender issues. So it was not on purpose, but in fact, it happens that the best paper award was given, or was awarded, in fact, to a paper which has 2 women in the first as first authors. So I'm very pleased to also to give the floor of our sponsors. I don't know who is the responsible for Wavecom, for example, if they want to say something. We would like.
I don't know if you can hear me. This is Mario from Wavecom.
Yes.
Well, congratulations to you all for the organization of such event. I was present about 21 years ago at Sesimbra in the CONFTELE in 99 as a researcher, also presenting an article, a paper. I know about the process, and I know about the great work that is being done by the academia and by the investigation teams in Portugal. It's very good that this event continues and is growing, and these young people are coming here with fantastic work, such as Sarah has been just awarded, and so congratulations. The companies are eager to get you collaborating with us, and I'm sure that great things can be done with your skills and with your will to innovate.
Okay, thank you very much. And now I would give the floor to a representative of OptiLink.
Hello?
Yes, there.
Hello. In name of OptiLink board, it was a pleasure for us to support the event. Congratulations for the organization. Thanks to call us, and we wish to all attendees great success in the studies. We know this know-how, all these papers are very important for the economy, for the companies, because this know-how is the base for the innovation process and for the product development. So I wish to all attendees, all academics, keep posting the papers and keep the good work, okay? Congratulations to the winners. Best regards for everyone, and keep safe. Many thanks.
Okay, thank you very much. And so the conference is finished, and I'm going to give the floor to Professor Salema to give the final words. I think I would like to pass this slide, but okay. Professor Carlos Salema was the honorary chair of this conference. So we'll meet again. That's what I have to say to all of you. And thank you very much. Professor Salema, please.
Thank you very much, Pedro. Well, let me just start by the end. And the end was a paper, and a fantastic paper. And I'd like to congratulate Sarah and Mariana for their job. And the subject of that paper interests me very much. They probably know, because I can still remember the first tests working with quantum key distribution in Aveiro quite a few years ago, maybe 10, 15, 16 years ago. So it's fantastic that after that time, young students come and write a paper that gets a prize. Congratulations to them. Now, I would like to thank all that made this conference possible. It is, I think you know that there's a lot of people that you don't see. You see Pedro, but you don't see probably 15 others that are behind Pedro, not supporting him, but making sure that everything works as it should. So thank you very much, Pedro. Thank you all of the organizing team and all the people that made this possible. I would like also to say just a special thank to the sponsors. It's fantastic that sponsors believe in us and believe in our work. So they go so far as supporting the prize. This is very nice and it's very good to have you with us. Thank you very much. As another thank you that I must say, it's to the Polytechnic. It's the first time it's not the first time, well, they participated in previous sessions, but it's the one they organized all by themselves. It's a lot of work and a lot of professional work, which they put together to have a nice conference, and the first CONFTELE in virtual on the waves. Well, using telecoms, that's basically what it should be all the time. So it's fantastic. And it is quite remarkable because although we learn how to use these things, there are always little things that you don't know and that happen while you're not expecting them to happen. So thank you very much for your work. It was really nice. And of course, the last but not the least, this conference only has a purpose if the authors want to submit papers, because with no authors submitting papers, there would be no conference. So all the authors, not only those who got the best paper award, but also the 10% that got that 10% best papers award, but also all the authors that submitted papers. So thank you very much indeed. And let's hope that we meet again, either in cyberspace or in real space in the next 1.5 to 2 years. We never know exactly what's going to happen. If everybody got a vaccine by then, and we can have a presential session, or we are still working only with telecoms. Anyway, thank you very much for the meeting. Congratulations for a very good job. Very well done. Thank you.
Okay, thank you. Bye-bye.
Bye.
Bye-bye.
In the beginning, we were very, very centered on telecommunications, hard, basic telecommunications. The first hint of what the 4G could be, we showed it in Expo 98 here in Lisbon. What we think is that in order to be ahead, you have to try to guess what's next.
The Internet of the future starts here. It's something that we like to testify by doing today what the public will see tomorrow, and by public we address the end user.
So we want to have everyone and everything connected. So this means people, of course, and our mobile phones. This means cars, this means drones, aerial drones, aquatic drones. This means the sensors that we have around, not only in the cities, but also in the parks and in agriculture. So to be able to connect all these elements. Some of them are moving, some of them are not.
We have in IT many areas of work. They go from pure telecommunications to applied telecommunications to very different areas, namely for biomedical applications.
It's not easy, especially in healthcare. Sometimes you don't feel that you are helping as much as you think when you go to the real world, so you need to measure very well. We do say that we save lives, we help to save lives, but this is 10 years of research to get to a position where we can start to help.
We work with a lot of hospitals. We have one of our research lines is connected with healthcare. We work with all the major hospitals, primary care centers. We deploy technology there. And another very big and important strategic line here is smart cities.
We would like a city where there is less noise, less air, the air quality is better, and we would like to have a better mobility in the sense that it is more amenable to ride bikes, that it is more, not necessarily faster, but it is it's not a stressful experience. Because we move a lot nowadays. And so, yeah, we are focusing on that, on improving the moving experience.
work is focused in, let's say, hot topics like smart city, smart home, smart health. And in this case, actually, always we think to implement the new technology in our common life.
What we expect for the next few years to come is to go to what we call the 5G. 5G is a general name that is an umbrella for many things. But what we are aiming for is to provide more data to more people and cover a lot of new applications.
The sophistication of the technology is